Okay, so here we go. This is the second section of 1.4 dealing with continuity, and I also throw into this section stuff from 1.5 infinite limits. Okay, so this is going to be the first of 4 different videos. Each video addresses a we'll call it a small question related to this essential question. So this first one, we are going to be asking, what does it mean to be continuous? And we are moving beyond now our, I would call it introduction to continuity that we've received in prior math classes, where depending on how your prior teacher explained it, it might have been, you know, a solid line. It might have been being able to draw the graph without being able to pick up your pencil. I don't know. I've heard it described in a variety of ways, but we're moving beyond that now into a technical mathematics-based definition of continuity. So here's our definition, in which 3 criteria have to be met. So a function is continuous if the following three conditions are met. Okay. Number 1. Okay. The first condition is that points have to exist. So we call it f of c exists. Okay. Now on the board when I was giving this lesson, I drew a picture of what this looks like, and so I'm going to go ahead and do that off to the side here just so we can kind of see. The point has to exist. So the issue would be with a graph like this one, right? We've learned in prior math classes that at this point, we'll call it C, that this is a discontinuity. And again, maybe it's because your teacher said, you know, it wasn't a solid line, or your teacher said because I had to pick up my pencil to move over the hole to continue the function. But whatever the case may be, we're usually pretty comfortable with that one being a discontinuity. But mathematically, why is that an issue? It's because your point doesn't exist. Okay? Number 2, your limit has to exist. And again, I then drew on the board this picture, which is we know that this type of piecewise function is discontinuous at this C because there was a break in my graph. Well, now we know based off of limits, okay, that this is a discontinuity because the limit doesn't exist. This does not agree, right, in terms of our limit dance. We have a disagreeing limit, and so this limit doesn't exist. Okay, and then our third and final one is that the limit that we find in number 2 there in evaluating our second criteria, that limit has to equal the point that I find in evaluating number 1. And so what that would look like is this type of function. Maybe something like this, where that's C. Because again, this third function, the issue is not criteria 1, I've got a point. We'll go ahead and trace this over. This here is my point, and I'll go ahead and call it P for now for point. And I've got a limit, so the issue isn't criteria number 2. My limit's right here. We'll call it L for limit. The issue is that third criteria. My limit is higher than my point, and it doesn't matter whether it's higher or lower, but the limit has to equal the point. That's that third criteria. It's only if all 3 of these are met that I can say, yes, my function is continuous. Now, in terms of this class and in terms of the AP test, you have to have these memorized. You need to know what these three conditions are. You need to be able to reiterate them in terms of supporting a conclusion you make, whether that conclusion is that a function is continuous or discontinuous, but you need to know what these are, and you need to be able to reiterate them. So this is going to be the end of the first video, because I want you to take a moment and before transitioning to the second video, quiz yourself on those. And my recommendation would be between each video, pause for a second, quiz yourself on the the 3 qualifications, because you have to know them. Okay?